Hello everyone, my name is Amina. I'm doing my master's in power engineering at Washington State University. I'm hoping to be graduated in fall 2019. The topic of my presentation is an overview of optimal power flow and economic dispatch in electricity market. We will discuss about the definition of optical power flow and economic dispatch. We'll talk a little about the history of OPF, an overview of OPF, OPF applications with a list of examples, the objectives and formulation with methodologies of optimal power flow. We'll wrap up with the challenges and shortcomings of OPF. So, what is optimal power flow? The definition says the OPF method represents the problem of determining the best operating levels for electric power plants in order to meet demands given throughout a transmission network, usually with the objective of minimizing operating cost. Why do we need OPF? An electrical power system shall be not only secure and reliable, but economically optimal and efficient, meaning that electricity shall be provided minimizing generation costs and transmission losses, and in general, meeting several economic, operational, and environmental objectives and constraints. What is economic dispatch? Economic dispatch is the short-term determination of the optimal output of a number of electricity generation facilities to meet the system load at the lowest possible cost, subject to transmission and operational constraints. The objective of economic dispatch is to minimize the cost of generation with equality constraints of load generation balance and inequality constraints of upper and lower limits on generating units output. It is defined as the process of allocating generation levels to the generation units in the mix so that the system load is supplied entirely and most economically. The purpose of economic dispatch is to determine the optimal power generation of the units participating in supplying the load. Early research on OPF used classical Lagrangian techniques for the optimal conditions, but neglected bounds on variables. In 1962, Carpentier published the optimality conditions for an OPF, including variable bounds, based on the Kuhn-Tucker conditions. This is generally considered the first publication of a fully formulated OPF. For economic dispatch, as early as the 1930s, the economic dispatch problem was solved by hand or specially developed slide rules using the principle of equal incremental loading, taking as long as 8 hours to complete. So that is a very slow process. Now in each electricity control room, the optimal power flow problem or an approximation must be solved many times a day, as often as every 5 minutes. Let us take a look at the overview of optimal power flow. We can solve optimization problem uses a classical objective function which minimizes the cost of generation. Function is to minimize the cost of equality and inequality constraints. The equality constraint is power balance at each node, power fluctuations, where the inequality constraint uses network operating limits, that is line flows and voltages, and also limits on control variables. Let's take a
Applications
look
of
about
OPF.
the applications
Where
of
actually we
OPF.
can use
Aiming at
this
various
optimal power
application
flow
domains,
method.
implementations of
Aiming at
OPF
various
differ
application
in terms
domains,
of the
implementations
model
of
formulation, the
OPF
level
differ
of
in
detail
terms
in
of
the
the model
representation of
formulation,
the
the level
system,
of detail
and
in
the
the
computational
representation of the
or
system,
algorithmic
and the
aspects of the
computational
solution
and
methodology.
algorithmic
Different
aspects
objectives
of the
call on
solution
different levels
methodology.
of details
Different
in the
objectives
model
can
and in the
call
representation
on
of
different
various
levels of
considerations.
detail
However,
in the
there is
model and in the
considerable
representation of
arbitrations
various considerations. However, there
involved
is
in all
considerable
aspects of the OPF.
attributions
Model
involved in
formulation,
all
level of
aspects
detail
of
in
the
the
OPF.
interconnected
Model
system,
formulation, level of
representation and
detail in
solution
the
methodology,
interconnected system
or implementation
representation
scheme.
and solution
Here is a
methodology
table
or implementation
that gives
scheme.
a simple
The
illustration of
following
OPF
table
application in power system.
gives a simple
Here are the
illustration
application
of
fields
OPF
and
application
the
in power
objective functions
system.
of
Here we
OPF
can see
model.
the application
For
fields
a real-time electricity
and
price
related
computing,
objective
the objective
functions of
function we'll be
OPF
using
model
is
that
the
can be
maximum
used.
social
We
welfare.
have
For a network
real-time
congestion
electricity
management,
price
the
computing,
objective
and
function
where
we'll be
we will
using
use the
is
maximum
minimum congestion
social
management.
welfare as the
For
objective
electricity
function.
transmission fee allocation,
Then
the
network
objective function should
congestion
be used
management,
is
where
minimum
the objective function will be
generation
minimum
cost or maximum
congestion
custom benefits.
management.
For
Then
availability
electricity
transmission
transmission
capability,
fee
that is
allocation, where the
ATC in
objective
short,
function will be
computing,
minimum generation
the
cost
objective
or
function of
maximum
OPM
custom
model
benefits.
that we'll be using is
For the
maximum
available
total
transmission
transmission
capability,
capability.
ATC computing, the objective function we'll be using for the OPF model will be maximum total transmission capability.
Here are
Here
some
are
typical
some
examples of
typical
OPF
examples
applications.
of
In
OPF
general, OPFs are
applications.
applicable
In
when
general, OPFs are
studying a
applicable when
problem that
studying
requires interactive use
either a
of
problem that
conventional power
requires
flows
interactive use
or
of
cases
conventional power
involving
flows
conflicting and
or
independent variables and
cases
requirements.
involving
The
conflicting
first
and
one
independent
of
variables and
OPF
requirements.
application is the base case
We can
development.
use
This is
OPF
perhaps the
in base
most
case
common OPF
development.
application.
This is
Well
perhaps the
conditioned
most
cases
common
are rapidly
OPF
attained.
application.
Dozens of base
Well-conditioned
cases can
cases
be
are
efficiently
rapidly
developed
attained.
following the same set
Dozens
of
of base
design
cases
rules.
can be efficiently
The next one
developed
is
following the
voltage
same set of design
instability.
rules.
Maximum transfers, that is PV
Voltage
curve approach, or
instability.
minimum compensation
Maximum
requirements, that
transfers,
is
that
QV
is
curve approach
VP
to
curve
attain voltage
approach or
stability
PV
are
curve
obtained in a
approach,
single
or
solution.
minimum compensation
Other
requirements,
constraints
that
such
is
as
QV curve
voltage
approach,
and
to
or
attain
thermal limitations
voltage
can be added.
stability
The next
that
one
are
is
obtained in a
economic
single
dispatch,
solution.
which is
Other
subject to thermal
constraints
constraints,
such
voltage
as
constraints,
voltage and or
interface
thermal
constraints,
limitations
that is
can be added.
stability, and spinning reserve
Then
constraints.
we
From
have
this
economic
dispatch,
dispatch that is
marginal
subject
cost and
to
transmission
thermal constraints,
bottlenecks
voltage
are
constraints,
easily identified.
interface constraints, that is stability, and also spinning reserve constraints.
The main objectives of OPF algorithm is economic dispatch, which means
The
minimum
main
cost
objectives of
losses, megawatt
optimal power
generation, or
flow
transmission
are
losses.
economic
We
dispatch,
want to
which
minimize
means
the cost and
minimum
losses.
cost, losses,
The next one is
megawatt
environmental
generation, or
dispatch,
transmission losses.
maximum power
Environmental
transfer,
dispatch,
minimum deviation
maximum
from
power
a target
transfer,
schedule,
minimum
minimum control
deviation
shifts
from a
to
target
alleviate
schedule,
violations,
minimum
least
control
absolute
shifts
shift
to alleviate
approximation of
violations,
control shift,
least absolute
maximize
shift
system performance,
approximation of
minimize
control
load
shift,
shedding, determine
maximize
control
system
setting,
performance,
and
minimize load shedding,
automatic voltage
determine
regulation settings
control
within the
settings,
specified limits.
and
So,
AVR
the
settings
main
within the
objective of
specified
OPF
limits.
is to maximize the system performance and minimize the cost and losses. The formulation of OPF. Optimal power flow is a set of computations to solve the power flow in a way that one or several objectives are optimized. The OPF, given an initial state of the system and a set of constraints determines the best possible values for the control variables that
The formulation
simultaneously
of
fulfill the
OPF.
constraints and optimize the
The
objective
optimal
function.
power flow
The
algorithm solves a
particularities of the powerful
nonlinear
problem
problem of
shall
the
be
following
accounted
form.
for and
There is a
caution
cost function
exerted when formulating the
FUX,
OPF,
which
and
we
when
need to
analyzing the
optimize. That
results,
is the main
including the
objective of
feasibility of the
OPF,
formulation as
which
pointed out
subject to
by 1.
HUX,
The OPF must
which
reflect
is
and account
inequality
for the
constraints vector of
characteristics
system
of the powerful
inequalities,
problem.
and
2.
that
The
includes plant
OPF
and
should include
transmission
the
system
mechanisms to
operating
deal
limits.
with non-feasible
And
solutions
the
instead
cost
of just
function is
declaring a
also
solution
subject
as
to
non-feasible and
GUX,
aborting
which
the
is the
execution.
equality constraints,
The
that is
optimal
the
power flow
vector of
algorithm
power flow
solves
equations.
nonlinear problem of the following form: to optimize a cost function that is FUX subject to HUX, which is the inequality constraint, and GUX, which is the equality constraint, that is vector of power flow equations. The OPF methods are broadly computed as conventional and intelligent.
Now we will
Conventional
take a look
methodologies
at
include
the
techniques
solving
like
methodologies of
gradient method,
OPF.
Newton method,
OPF
quadratic
has been
programming
frequently
method,
solved linear
using typical
programmable
method, and interior
optimization
point
method and
method.
technique on computer using
In the
MATLAB and
intelligent
different
methodologies,
optimization
it
toolbox
includes
like
the methods like genetic
fminecon that has
algorithm,
become standard
particle
practice
swarm
to solve a lot
optimization,
of optimization
and
problems.
the ant
However,
colony method.
the OPF methods are broadly grouped as conventional and
OPF has been
intelligent.
frequently solved
Conventional
using
methodologies
typical
include
optimization method
techniques
and
like
techniques
gradient method,
on
Newton
computer
method,
using MATLAB and
quadratic
different
programming
optimization
method,
toolbox
linear
like
programming method,
fminecon
and
that
interior
has
point
become
method.
standard practice to
Where
solve a lot
intelligent
of
methodologies
optimization
include the
problems. This
methods
toolbox
like
from MATLAB
genetic
has 3
algorithm,
algorithms
particle
with
swarm
several options for
optimization,
Hessians, including fmincon,
ant colony
trust regime,
algorithm, and artificial
reflective
neural
algorithm, fmincon,
networks.
active state algorithm, and fmincon interior point algorithm. The table here is
Here is
showing
a
appropriate
table that
methods for
shows
solving
appropriate
OPF.
methods for solving
The objective
OPF.
functions to be optimized, suitable methods,
For
and
economic
reason.
dispatch,
For
the
economic
suitable
dispatch,
methods
the
are
suitable method is
linear
linear
programming
programming
and
or
Newton
Newton
method
method
because
because
it's
it's
the
fast.
fast
For
method. For economic
economic
dispatch with
dispatch with
non-smooth
non-smooth
cost
cost
function,
function,
the
the
artificial intelligence is the suitable method
artificial
because it's
intelligence
a
is the
nonlinear
suitable method
problem.
because it's a non-linear
For
program.
reactive power
Reactive power
optimization, the
optimization,
suitable methods are
QP,
QP,
AI, and
AI, and
IP
IP.
is the suitable
For
methods
IP, it
because it's
stands
accurate.
for
For
interior
congestion
point
management,
method. The reason for
artificial
choosing these methods
intelligence is
is
the suitable
accurate
one
methods.
because it's
For
multi-rated
congestion
nonlinear problem.
management,
For
the
social
suitable
fortune and for optimal
method
location of
is
fact devices,
artificial
the
intelligence because it's
artificial
multi-rated
intelligence
nonlinear
is the
problem.
suitable method
For
because,
social fortune,
again, it's
again,
multi-rated and
for
multi-purpose nonlinear
quadratic
problem.
portion and artificial intelligence, the reason is multi-rated nonlinear problem. Optimal location of fact devices, again, artificial intelligence is the suitable method because it's a multi-purpose nonlinear problem. So we can see for every nonlinear problem, the most suitable method for solving OPF is artificial intelligence method.
Here are a few challenges of
In this
OPF
last
and
slide, we will
shortcomings of
be
OPF.
discussing on
And the challenges,
the
the first one is
challenges and
global
shortcomings
optimization
of
control
optimal
versus
power
local
flow.
regulation. It is important to
Challenges.
distinguish
Global
between global
optimization
optimization
control
control
versus
and
local
local
regulation.
regulation
It is
control.
important to
Once the
distinguish
concept is
between
grasped, it
global
will end
optimization
many hours
control
of
and
heart
local
searching to
regulation
comprehend
control.
why an
Once the
OPF
concept is
appears not
grasped, it will
performing
end many
what
hours of
one
hard
expects it to
searching
be.
to
The
comprehend
next one is
why
level
an
of
OPF
security.
appears
One
not
important
performing
network modeling issue
what
of
one
OPF
expects
is
it to
the
be.
strategy of dealing with
The
network
level of
security.
security. One important network modeling
The
issue of OPF
the
is the
requirement that
strategy of
there must
dealing
be a
with
feasible
network
solution
security.
in
The
the
requirement
intact
that
network
there
as well
must be a
as in the
feasible solution in
post-contingency
the intact
network.
network as well
There are a
as
couple
in
shortcomings of
post-contingency
OPF.
networks,
Among
that is,
them are
after a fault
non-convergence due to
on one
infeasibility
or
in
more
common
items
in
of
OPF
generating or
investigations,
transmission
learning
equipment.
curve, and conventional
This is
versus OPF treatment
this
of
issue
locally
centers
controlling
on
generator
the
constraints.
relationship
The
between controls
conventional
in the
treatment of
intact and
generator constraints is
post-contingency
difficult
network.
to model in OPF
Then
program.
control
Apart from all
priority.
this,
It is
OPF is a
important
very important
to know about
algorithm
the
in power
control
system
priority
optimization.
in order
Thanks
to
everyone.
control variable in order the control variables in an OPF are optimized. Common to many commercially available OPF, the users are normally given freedom to specify which controls are allowed to move first, second, and etc. This gives rise to a control priority list, that is, phase shifter taps, tie line interchange targets, generator megawatt set points, and load shedding. There are also shortcomings of the OPF problem solving system. Few are non-convergence due to infeasibility is common in OPF investigations. Other one is learning curve. There is a steep learning curve before results are obtained. The last one is conventional versus OPF treatment of locally controlling generator constraints. The conventional treatment of generator constraints is difficult to model in OPF programs. Thanks, everyone.